Okay, so today is again related to chapter 13 and 15. In the previous class, we already talked about gas mixtures, and so today first we will solve another example related to gas mixture, and then we'll move towards the next chapter, which is chapter number 15. Okay, which is also related to the chapter number 13. Okay, so first you have to read the statement. A perfect gas mixture consists of 4 kg of N2 and 6 kg of CO2 at a pressure of 4 bar and temperature of 25 degrees Celsius. So you have to calculate constant specific heat at constant volume and constant specific heat for pressure of the mixture. Okay, so note it down, it is a mixture. Okay, so previous cases we use dCV and Cp value for some single gas. Okay, so for example, we are talking about air, so we have the value of
काटने का नहीं कहा था ले आए बस.
Okay, so we already have the value of Cp and Cv of air with us, but in order to find the mixture Cp and Cp, so we will see that how to proceed with this type of problem. If the mixture is heated at constant volume to 50 degrees Celsius, find the change in internal energy, enthalpy, and entropy of the mixture. Okay, so these are the required things you have to find. So you have to note it down the data, then move towards the solution. Okay, so before starting, we have to know the value of Cv and Cp for the individual gases. Okay, so you have to go to table 8, or you can find the properties table in the property of Cp and Cv values in the thermodynamic table at the end of the book. Okay, so first I can just write the Cp value for N2, which is equal to 1.041 kilojoule per kg dot Kelvin. Okay, so similar way we also have to note down the value of Cv value for N2, which is equal to 0.745 kilojoule per kg dot Kelvin. And now the Cp value of CO2, which is the second gas, which is equal to 0.842 kilojoule per kg dot Kelvin, and in the similar way Cv value of CO2, which is equal to 0.653 kilojoule per kg dot Kelvin. So these two values for both of the gases are required for the solution. Okay, so now from the data, we already know that the mass of N2 is mentioned in the problem statement, which is 4 kg. Similar thing, mass of CO2 is also mentioned in the question, which is 6 kg. Okay, so now pressure of the mixture is also mentioned, which is equal to 4 bar, and temperature, which is, you can say, initial temperature, which is 25 degrees Celsius. So you have to put in the Kelvin, it will be equal to 298 Kelvin, and temperature of the final point, which is equal to 50 plus 273, is equal to 323 Kelvin. Okay, so now the first thing which is required is to find the Cp and Cv value of the mixture. Okay, so we can use the simple relation from which we can easily find the Cv value of the mixture. Okay, so we can say that mass of N2 plus mass of CO2 multiplied by Cv value we can say it will be the mixture Cv value is equal to mass of N2 Cv value of N2 plus mass of CO2 and Cv value of CO2. Okay, so we can easily write this type of equation because if we multiply the mass of both of the gases with the Cv mix, okay, so we will easily get the right hand side of the equation. Okay, so now here our required thing is to find Cv value of mix. So this is known to us, this is known to us, this is known to us, this is also known to us. Okay, so we can easily find the value by using this relation. Okay, so simply we can say 4 plus 6 Cv mix, which is equal to 4 into 0.745, which is the value of Cv for N2, okay, plus mass of CO2, which is also mentioned in the question, which is 6 kg, and Cv value of CO2, which is equal to 0.65. Okay, so now here if I can just solve for Cv mix, the value will be equal to 0.6898 kilojoule per kg dot Kelvin. Okay, so the Cv mix value are known to us now. Okay, so similar procedure we have to adopt for the Cp value mix also. Okay, so what we have to do is just by replacing mass N2 plus mass CO2, and here you can write Cp mix. And similar procedure you have to mention in the right side also Cp value instead of Cv value. So Cp N2 plus M CO2 Cp CO2. Okay, so now just you have to plug the value of Cp value which is mentioned over there. Okay, and you can solve for Cp mix. Okay, so you can easily find the value of Cp mix by using this relation, which is 0.91 0.216 kilojoule per kg dot Kelvin. Okay, so this is the first thing which is required in the question. So you have to note it down, and then we'll move towards the second part. If you have any question, you can also ask. Okay, so now the next thing which is required is to find the change in internal energy. So delta U is equal to mCv T2 minus T1. Okay, and this is we are talking about mixture because we have to find the delta U for the mixture. So M value is basically combination of both of the masses. Cv value here we have to use the Cv value of mixture, which we already find in the previous slide. Okay, so which is 0.6898. 0.6898. You have to use the Cv value of mixture. T2 value is known to us from the question, which is 323, and T1 value is 298. So you have to just solve this and you will get the 172.45 kilojoule value of delta U. Okay, so in a similar way, you also have to find the change in enthalpy, which is equal to mCp T2 minus T1, and here also it is the mixture. Okay, so again 4 plus 6, and now we have to use the Cp value of mixture. so which is 0.9216 from the previous slide, and T2 value is 323 and T1 value is 298. So if you can solve it, you will get the value of delta H, which is 230.4 kilojoule. So now the next thing which is required is to find the change in enthalpy, which is change in entropy. Sorry. So delta S, which we can also write that in the form we know from the previous chapter, from the gas power cycle as well, and from the thermodynamic one also, that CV log of T, T2 over T1 plus log gas constant R log of E V2 over V1. So this relation we already see in chapter number 7 as well, okay, when we are talking about gas power cycle. Okay, so it is mentioned in the question that if the mixture is heated at constant volume, okay, so from here we can easily say that this term can be eliminated from this one because it is the constant volume. Okay, so then we can just put the value of CV mixture over there, okay, and delta S, because it is we are talking about delta S, so we have to multiply the mass also. Okay, so delta S is equal to mass, which is 4 plus 6 CV value of mixture, because this is we are talking about a mixture, and CV value is 0.6898 and log of 323 divided by 298. So if you can just solve it, you will get the delta S value also. So 0.55557 kilojoule per Kelvin is the value. So both of the things which is required. So delta U, delta H. Now the third thing is delta S is also known. Okay, so this is the solution for this type of question. If you have any question, you can also ask. Okay, so now moving towards the chapter number 15, which is the chemical reaction. Okay, so and that chemical reaction we are mostly focused on the combustion processes which take place in your internal combustion engine or either in the steam power plants. Okay, so now chemical reactions are the processes during which the chemical composition of the component changes. Okay, so this means that depending on the rearrangement of chemical bond, so we already know that there are two processes involved in the chemical process, chemical reaction. First, either we have to produce heat energy, and we represent it as a exothermic reaction, and either we require heat energy, which is called endothermic reaction. So combustion is one of the most important chemical reaction, particularly in study of thermodynamic system. It is a chemical reaction during which a fuel is oxidized and a large quantity of energy is released. Okay, so we already see whenever we have to produce combustion, we have to mix fuel with the air. Okay, so air is basically the source of oxidization. Okay, because if we do not have to supply enough amount of oxygen, either it will be not a good combustion process, or either we cannot initiate the combustion as well. Okay, and similar way, if we supply excess amount of oxygen, still it will be not good for the combustion process. So we have to manage some certain portions. Okay, so which we will discuss what is that type of things which we require to produce accurate combustion processes. Okay, so now when we are talking about combustion, the fuel is the important component. Okay, so in most of the the material that can be burned to release thermal energy, which is called the fuel. And most common type of fuel consists of hydrogen and carbon. Because we already know that when we are talking about different fuels, so hydrocarbon fuels are most commonly used in internal combustion engine, and we denote it as CNHM. Hydrocarbon fuel exists in all phases like coal, gasoline, natural gas. Okay, so the coal is basically the natural type of hydrocarbon. Okay, so then there are different artificial type of hydrocarbon as well, where we have to mix different type of artificial things to produce some type of um, hydrocarbons or this type of things. Okay, now we have to categorize hydrocarbons into three categories. So first is the solid hydrocarbons. So solid hydrocarbon, basically the coal is one of the form of the solid hydrocarbon. Coal also contain different amounts of oxygen, hydrogen, nitrogen, sulfur, moisture, and ash. And it is difficult to give an exact mass analysis for coal since its composition varies considerably from one geographical area to the next. Okay, so this is the one form of the hydrocarbon, which is the solid hydrocarbon. Then it's come to the liquid hydrocarbon, which most commonly we use in the our IC engines. Okay, so this is basically most liquid hydrocarbons fuels are a mixture of numerous hydrocarbons and are obtained from crude oil by distillation. Okay, so distillation basically means that we have to separate different hydrocarbon from the crude oil. Okay, and that distillation will take place at different temperature. So as we move towards a different temperature of distillation, so first stage we get the gasoline, second stage we get the kerosene, then there will be diesel fuel, and then it is a fuel oil. Okay, so these are the sources of the these sources of the gasoline, kerosene, diesel come from the crude oil by the distillation process. Okay, so the most volatile hydrocarbon that vaporize first, forming what is known as gasoline. Okay, so this is you already see the picture that gasoline come at the first stage. Then the less volatile fuels obtained during distillation are kerosene, diesel fuel, and fuel oil. And the composition of particular fuel depend on the source of the crude oil as well as the refinery. Okay, although liquid hydrocarbon fuels are a mixture of many different hydrocarbons, but they are usually considered to be single hydrocarbon for convenience. So, for example, for the gasoline, we just say that it is the octane or C8H18, and although it is a combination of different hydrocarbons, but we still represent with the only octane. Okay, and then the diesel fuel, which we represent as a low decane, which is C12H26. So this is the way to represent the hydrocarbons for the fuels. Okay, so now coming towards the third type of hydrocarbon, which is gaseous fuel. Okay, so gaseous fuel also used in our internal combustion engine. Okay, so gaseous fuel hydrocarbon that is a form of natural gas, which is a mixture of methane and smaller amount of other gases, and is often treated as methane CH4 for simplicity. And natural gas is produced from gas well or oil well, rich in natural gas. It is composed mainly of methane, but it also contains small amount of ethane, propane, hydrogen, helium, carbon dioxide, nitrogen, hydrogen, sulfate, and water vapor. Okay, so we also, I hope you already know that the use of hydrocarbon in the form of gaseous state is in the CNG or LNG. Okay, so CNG is one type which we use frequently in previous days in our automobiles as well. It is basically the compressed natural gas. Okay, so it is stored either in the gas phase at a pressure of 150 to 250 atm, and then the liquid phase at minus 162 degrees Celsius, and which we call as a LNG, which is a liquefied natural gas. So liquefied petroleum gas is a byproduct of natural gas processing or the crude oil refining. It consists mainly of propane, and thus LPG is usually referred as propane as well. Okay, so these are the fuel which we commonly use in the internal combustion processes. Okay, so this we already talked in the previous slide. Okay, so now important thing is that here is table 15 dash 1 from your book. Okay, so which fuel we have to select for the combustion process is depend upon how much energy content that specific fuel carries. Okay, for example, we have the gasoline. So gasoline contain 31,850 kilojoule energy per liter. Okay, so similar if you can compare with the CNG, it consists of 8,080 kilojoule per liter. Okay, so that is our requirement. What is our end thing which we have to achieve? For example, if we want to get more energy content from the limited amount of fuel, okay, so then we have to select our energy content of the fuel, okay, by using this table. Okay, so sometimes we can use in our problem statement as well this type of data. So this we already talked in the previous slide that the most important part for the combustion process is the oxidation, where we have to add oxidizer to the fuel. Okay, and we already know that commonly we use the oxidizer as a air. Okay, so what is the reason why we have to use only air? There are other oxidizer as well. Okay, so why we have not to choose other oxidizer? So only the answer is because air we can easily get free of cost. Okay, rather than other gases which we have to pay the price for this. Okay, so that's why we have to use air most commonly. And on a mole or a volume basis, dry air is composed of 20.9% O2, 78.1% N2, and 0.9% argon and small amount of CO2, helium, neon, and H2. Okay, and in the analysis of the combustion, when we have to analyze the combustion processes in the theoretical way or in the form of problem statement, so what we have to do is we just approximate that our O2 is 21% and N2 is 79% by mole number. Okay, so we do not consider that the gases which are in the small amount which is present in the mixture. Okay, so this is the procedure. Okay, so this we already know that if we have two O2 and N2. Okay, so 1 kilomole of O2 and 3.76 kilomole of N2 make 4.76 kilomole of air. Okay, so this is the standard terms. Okay, 1 kilomole and 3.76. When we are using that air is used as oxidizer, so we just have to know that we are talking about 1 kilomole of O2 and 3.76 kilomole of N2. These are the standard terms. Okay, so now if you remember that when we are practicing the problem of Otto cycle and diesel cycle, for the combustion processes inside the combustion chamber, we need our fuel that the temperature of the fuel got above its ignition temperature. Okay, so in the Otto cycle, we have to achieve this by using the spark plug, and in the diesel cycle, we achieve by using the increasing of pressure inside the combustion chamber. Okay, so this is the important time, the ignition temperature. Okay, so because every time whenever we have to start the combustion, we have to raise the temperature of the fuel above its ignition temperature, then the ignition process started. Okay, and the minimum ignition temperature in atmospheric air or approximately 260 degrees Celsius for gasoline, 400 degrees Celsius for carbon, 580 degrees Celsius for hydrogen, 610 degrees Celsius for carbon monoxide, and 620 degrees Celsius for methane. Okay, so from these values you can easily say that which fuel can easily be ignited. Okay, so it is a gasoline which is easily ignited, and for the methane we need high ignition temperature to produce the combustion. Okay, so then the portion of the fuel and air must be in the proper range of for the combustion to begin. Okay, so this I already explained that whenever we have to produce the combustion process, so we have to supply some specific amount of air. Okay, we cannot supply less amount of air, and we also cannot supply the extra amount of air, okay, for the combustion process. Okay, so for example, the natural gas does not burn in air in concentration less than 5%, or it also cannot burn for the greater than about 15%. Okay, so there is a specific ratio which we have to use, so which we will discuss in the next slide. Okay, so whenever we are talking about the combustion processes, so there is a chemical reaction, and for chemical reaction, one part is the reactant. Okay, so reactant is basically the fuel and air, and then your product. Okay, so product comes from the either it is a byproduct. Okay, as a result of your combustion process. Okay, and the mass and number of atoms of each element is conserved during the chemical reaction, or either you can say it is a combustion reaction. Okay, so this we already know from the previous lecture as well. Okay, so this we already talked about in the previous slide, that the mass is conserved during the chemical reaction. So if we are taking 12 kg of carbon, 32 kg of O2, so it produces 44 kg of CO2. So it means the mass is conserved during the chemical reaction. So air fuel ratio is basically the term which we have to use to define that how much air and fuel ratio we have to use for producing the combustion process. Okay, so this air to fuel ratio is either specified by the manufacturer or when you are designing the engine. So you have to calculate that what is the air fuel ratio in order to produce the accurate combustion process. So air fuel ratio is basically the mass of air to the mass of fuel for the combustion process. So basically, if you can say that if you have fuel 1 kg and air 17 kg, and you have to react these things in a combustion chamber, so air fuel ratio becomes 17 and your product is 18 kg of your the product. Okay, so now, okay, so here we are representing air to fuel ratio in the mass term. Okay, so we can say it is on a mass basis. So we can convert it into the mole basis as well by using this relation, number of mole into molar mass. Okay, so simply we have to just plug the value, number of mole of air, mass of air over number of mole of fuel and mass of fuel. Okay, so if we have to represent air fuel ratio in the form of molar, okay, so we can easily develop the equation. Okay, so now another term which is we can say that it is the fuel air ratio. So fuel air ratio basically only the reciprocal of air fuel ratio. Okay, so sometimes we use fuel air ratio and sometimes we use air fuel ratio. Okay, so these are the terms we can use in the. Okay, so now coming towards one question which is example 15-1 from your book. Okay, so you have to read the statement, then you will see that how to solve this. Okay, so here it is mentioned 1 kilomole of octane C8H18 is burned with air that contain 20 kilomole of O2. Okay, so it is shown in the lecture as well. Assuming the product contain only CO2, H2O, O2 and N2. So you have to determine the mole number of each gas in the product and the air fuel ratio for this combustion process. Okay, so you have to note it down the data and then you put the solution. Okay, so in order to calculate the air fuel ratio, okay, so first we have to find the number of moles that are present in the products. Okay, so in order to find the number of moles in the product, first we have to develop the equation. Okay, so because this is not a chemistry course, so I will give or provide the chemical reaction equation in your problem statement whenever you can see this type of question in your final exams. Okay, so you do not need to remember the equation or okay, for this course. Okay, so now coming towards the equation, so the equation becomes C8H18, which is our fuel, plus 20 mole of air. So basically, air is a mixture of 1 mole of O2 and 3.76 mole of N2. Okay, so these are our reactants, and now by using the combustion, we get the products. So in the product, from the figure, you already saw that we get in the product CO2, H2O, O2 and N2. Okay, so we get X mole of CO2, then we get Y mole of H2O, and we also get Z mole of O2, and you can just write W mole of N2. So these abbreviation you can use as per your choice. Okay, so first we have to balance the equation, okay, so that we can easily find the number of mole which are associated in the products. Okay, so first we will start by balancing the carbon on both left and right side. Okay, so we can see that 8 carbons are present on the left side and X number of carbon is present in the right side. Okay, so from here we can say X is equal to 8. So similar procedure for balancing of hydrogen. So hydrogen is 18 on the left side and 2y on the right side. Okay, from here we can say y is equal to 9. And in the similar way, you have to do the balance for the O, and it's the monatomic oxygen. Okay, so monatomic oxygen we can say 20 into 2 at the right side, at the left side, sorry, and now on the right side it is 2x plus y and plus 2z. Okay, so now we have the value of x and y with us from here. So you just have to plug these value into the oxygen balance and you will get the value of z as 7.5. Okay, similarly you have to apply for the balance of N2. Okay, so balance of N2 for the left side you will get 20 into 3.76 mole of N2 on the left side, and on the right side you will get the value which is equal to W. Okay, so if you can just solve it, you will get W as 75.2. Okay, so now we have all the moles that are in the products. Okay, so you have to note it down, then we move to the next one. Okay, and you can just plug the value into the equation. So it becomes C8 H18 plus 20 O2 plus 3.76 N2, which turn out to be 8 CO2, 9 H2O, 7.5 O2 and 75.2 N2. Okay, so now this is the equation which we have to use for the further analysis of the air fuel ratio. Okay, so you have to note down this equation because this is an important equation and because this is the reference equation which we have to use. Okay, so now coming towards the main part, which is to find the air fuel ratio. Okay, so air fuel ratio is basically mass of air or mass of fuel. Okay, so we can just make this equation in the form of mole basis. So n into m of air over n into m of fuel. Okay, so from here we can already note from the equation for the chemical equation that number of mole of air is basically 20 into 4.76. Okay, which is the fuel basically. Okay, so now which is basically the oxidizer. Okay, so now here we have to multiply molar mass of air. So you can either go to table A1, okay, for thermodynamic A1. Okay, so from there you can easily get the value of molar mass of air, okay, so which is I think 29 kilogram per kilomole. Okay, so in the fuel we have two terms, which is carbon and H2. Okay, so first we have to know the carbon moles. Okay, so carbon mole we'll already find from the previous step, which is 8 mole of carbon, and your molar mass of carbon is 12, and you have to add H2O moles. So H2O moles is 9 from the chemical reaction. So you have to correlate with the chemical reaction for this. Okay, and then you can say it will be 2 kg per kilomole of H2. Okay, so if you can just solve this, you will get 24.2 kilogram air divided by kilogram of fuel. Okay, so this is the procedure you have to adopt for finding the air fuel ratio. Okay, so now the solution is completed. If you have any question, you can ask me. Then go to the next one. So at this point we will stop now, because the question which you have to solve is to by just replacing this 20 kilomole to 40 kilomole. Okay, so now you have to again balance the equations. Okay, this same equation will be used. Okay, so which we already discussed in the this class. Okay, so just you have to replace 40 kilomole instead of 20 kilomole, and you will get 0.2 absolute moles for it. Okay, and you can submit it by tomorrow, or either you can submit it by tonight. Okay, so I think I have already announced to the previous both of the section, which is the rest of full section. So I will announce to you also, okay, that your assignment weightage for the current course is 20%, and quiz weightage is 10%. Okay, so quiz we already arranged one quiz which we already performed. Okay, now the next quiz you will expect in the coming week. Okay, so the two quizzes we have to take for this session, and the assignment which we have to take is 4. Okay, so 3 assignment I have already, so 3 assignment is already completed, so 1 assignment is remaining. Okay, so what I have to do is that for this class, for all the question which I have assigned at the end of this class, which is you already solved, most of the students already sent it to me. Okay, so that assignment takes 6 absolute marks. Okay, so this is the one assignment which I say collectively as a which is a collection of all the assigned questions which I assign at the end of the class. Okay, so it's mean that the student who have already sent it to me, there is no issue for them. But for the student who didn't send it to me either one assignment, because many of the students who didn't send it to me on one question as well. Okay, so they didn't have sent it to me one question. Okay, till this date. Okay, so that means they are losing 6 marks. Okay, so it's your responsibility. You have to send it to me within 15 days. All the question which is remaining at your side. Okay, so you have to go through my recorded lecture and find out what are these questions. Okay, and send it to me within 15 days. Otherwise, you will lose straight forward 6 absolute marks. Okay, so if you have any question, you can ask me, and then we will just stop at this point and close the lecture.
सर
जी
सर नेक्स्ट क्विज का सिलेबस क्या है?
अच्छा, नेक्स्ट क्विज का सिलेबस आपके पास maybe from the gas power cycle. We will take from the gas power cycle, because that is the remaining topic. Rankine cycle is already done. Okay, so you can expect the quiz from the Otto cycle, from the diesel cycle, and from the dual cycle. Okay, so these 3 cycles you have to go through it, and but quiz is very easy. Okay, so I will because I will take most probably the quiz on the next Friday.